We are a biomedical engineering senior design team from Drexel University, and we are presenting our project, the Thigh Walker, which is an assistive mobility device for pediatric patients with lower limb injuries. There are over 24,000 lower leg fractures and sprains in children 5 to 7 per year. The lower leg consists of the knee, shin, and ankle, and once the leg is injured, it can bear almost no weight. So because of this, the children need a way of moving around that doesn't further injure the child. These types of injuries have a large impact on both the children and the caregivers. For the children, impaired mobility limits the activities they can take part in, like walking and climbing stairs, and this can affect them mentally. In terms of the caregivers, the current solution to this problem is for them to carry their injured child around, which affects their daily life and could impact workability. So most people would think of crutches as the obvious solution to this problem. However, children in this age group are not able to use them. When speaking with our clinician, Dr. Nath, he told us that these children aren't mature enough to understand how to use the crutches properly. And when conducting our own research, we found that the children aren't neurologically developed enough to synchronize their upper and lower body movements. There are other existing solutions aside from the caregiver carrying the child, but they each have limitations. The pediatric walker and the wheelchair both cannot go upstairs, require more complex coordination, and can be large and/or heavy, and crutches, as we just discussed, are not a viable solution either. This led us to design the Thigh Walker, where you can see the conceptual design on the left and the prototype on the right. This design targets the fundamental issue by not requiring the user to use upper and lower body coordination. Taking a closer look at the components of our design, we have the plastic thigh support at the top where the thigh sits and where the weight is redistributed to. To prevent the leg from slipping, Velcro straps are secured across the top of the thigh, and the device is bent to create a 35.5-degree hip angle, which requires a compression force from the Velcro straps at a safe enough pressure. Below, we have an adjustable clamp to adjust the height of the device, and at the base, we have an optional attachment to help extend the leg outward for knee injuries. Now, we'll demonstrate how the prototype is intended to be fitted and used. First, the leg is lowered into the upper thigh support and strapped in as tightly as possible. We also included an additional Velcro strap that can be moved along the lower main shaft and used to secure the lower leg and prevent it from freely swinging while in use. With the assistance of an adult, the device can be adjusted with the adjustable clamp. This clamp has a flip lever to loosen the grip and allow the metal tube to slide up and down. The clamp can also be further tightened by using a screwdriver. As a note, the bent leg and the guidance of the wall and another person were in place for safety reasons, and they are not a part of the intended use. This has been an overview of the Thigh Walker. Thanks for watching.